an incident several years ago on a small ro-ro ship where she'd loaded large caterpillar pieces, approximately 18 tons each, improperly secured. One of them broke free on a relatively empty deck, which was the unfortunate part, and was moving about 20 metres across the deck from one side to the other, and did indeed in the end up puncturing the ship's hull.
The forces affecting ships in rough sea conditions are formidable. For safe navigation across the world's oceans, we need to understand the effects on ships and cargo. Failure can risk ship and cargo and cause loss of life. When cargo is lost or damaged in transit, the consequences severely harm the prosperity of the shipping industry. It is one of the most common causes of insurance claims, costing millions of dollars a year.
There is always cargo being damaged at sea. The unfortunate thing is that when you do get damaged, that damage is normally of high value or abnormal loads, and it's these type of cargoes that cause the industry the problem.
But many such losses could be avoided if only greater care was taken during the loading and securing of a ship's cargo. So who is responsible for stowing cargo aboard ships? How is it secured to ships' decks? And what checking and monitoring regime should be imposed during loading and voyage? It is mostly stevedores who stow and secure the cargo, but they do not sail with the ships. Their lives and safety are not at stake. In many ports around the world, stevedores are hard-working, skilled and efficient. But sometimes they can be less so, often due to commercial pressure.
They must jump somewhere here, of course.
It is therefore the responsibility of ships' officers to understand the methods and techniques that should be used for securing cargo and the reasoning behind them, and make sure that they are applied correctly and thoroughly. Their lives and safety are at stake. Every ship carries a cargo securing manual, a volume written specifically for the ship and the cargo it has been designed to carry. In addition, the International Maritime Organization, the IMO, has produced a code of guidelines supplemented with annexes 1 to 13. It is an essential guide for seafarers to the securing arrangements of all types of cargo. This training package emphasizes the importance of this code and sets out to encourage those ship's officers responsible for cargo stowage and securing to apply it and understand the forces of nature it addresses. There are 3 general classifications of cargo stowage systems for different ships: standardized, semi-standardized, and non-standardized. For standardized systems, everything is pre-calculated according to class rules and documented in the cargo securing manual. Masters and officers must follow approved plans and permissible deviations, but should always check the stack weights, lashings, and weight distribution to ensure that where possible, heavier items are stowed at the bottom. With semi-standardized systems, pre-calculations are necessary and results are categorized by simple parameters detailed in the cargo securing manual, allowing fast and appropriate decisions on securing measures. With non-standard cargo, there can be no fixed rules. There are no worldwide standards yet agreed. Therefore, seafarers must refer to the IMO Cargo Safety and Securing Code guidelines, apply them, and equally apply common sense and professionalism.
The bill of lading says that the carrier will carry the cargo safely to destination, and therefore it's the ship and it's the crew that must make sure that the cargo is safe. If you've got a project cargo running and you've got a generator which is due to arrive in January for a project, say $1 billion project, which is going to come on stream in July, and that generator arrives damaged, and they have to build a new one and bring it out from origin, you could put the whole project back 3, 4, 5 months.
Well-managed cargo must be stowed so as to maintain the stability of the ship, especially in rough seas, and to ensure that it can be offloaded quickly and efficiently according to the schedule and ports of call. Bear in mind that if part of a cargo is unloaded at the first port, this could affect the securing of the remainder on the next part of the voyage. There are 3 principal stowage patterns: cross stowage, side stowage, and single stowage. With cross stowage, the cargo is tightly packed and secured against the ship's sides and bulkheads. Again, using the ship's structure, side stowage may involve items of varying dimensions and weights. Single stowage is the most difficult. These items may be stowed on deck or in a hold, but all need securing on all sides, and so space around them must be considered. A detailed plan must indicate the order and positions. Certain large items will need a lashing plan for their securing to the ship's deck. The process starts here at the shipping company's office, where an experienced loadmaster, normally an ex-captain or chief officer, works out a formula as the orders come in. His plan is arranged according to weight and schedule.
Is it a bottom stowing cargo or a top stowing cargo? Because all the cargo is stacked one on top of the other. The strength of the cargo, the length, width and height, and where it will be placed on the ship.
But all cargo is different, and many items, such as this 250-ton generator, present particular difficulties and hazards.
Has it even got points for securing? Many a times we get lifts, which themselves have no point of securing. But from our point of view, the stability of the ship comes primarily into consideration.
The plan must be a good foundation for the intended stowage, but must be flexible enough to accommodate last-minute changes. Here, the load manager discusses the plan with the stevedore manager. Changes are inevitable.
To put them down there, but this has to go under deck now. This is wrong on the plan. They have now come from Paris and said that we can load the 2 heavy cases there.
The ship's schedule is tight and delays must be avoided, but even the best-made plans can be upset.
Normally all cargo should be here when we start loading, but that's not the way it is in reality. Some cargo is in the barges, some cargo is coming still by railway, and some cargo is just delayed to some reasons and it's not here when we start loading the ship. And so then you must look at the loading plan and try with the availability of the cargo, start with 2 or if possible 3 gangs.
As the stowage plan is revised, the ship's officers must be extra vigilant to be certain the changes are followed and the ship is being loaded and secured correctly. They know what conditions are waiting at sea.
If the cargo is secured and becomes part of the ship, then you should have no difficulty with the cargo. It's when the securing is wrong or it's not made to be part of the ship that you get the difficulty.
If the lashing of the cargo is poor, it'll break loose and will definitely destroy the ship itself.
During a storm, a ship is subject to tremendous forces. Even experienced seamen do not always fully consider their effect on the cargo. They may sail with it secured well below what is necessary. As the ship is moved in all directions, pitching, heaving and rolling from side to side, the cargo is subjected to continually changing acceleration forces. These also vary according to the cargo's location. As the ship rolls, transverse forces to port and to starboard pull the cargo in each direction. The effect on the lashings is to stretch and compress them alternately, reducing their tension. As a ship rises on the swell, gravity pulls down, effectively making the cargo heavier. Items can sometimes double in weight. When the ship reaches the full extent of the pitch and begins its downward movement, the inertia of the cargo makes it effectively lighter as it tries to continue in the upward direction. At this moment, two things happen. First, its contact with the deck becomes weaker, which means there is less friction. And second, with the ship and cargo moving in opposite directions, the lashings stretch as the strain increases. The opposite occurs when the ship reaches the lowest point in the pitch, when the cargo is drawn in the opposite direction, putting less strain on the lashings, effectively loosening them. If the lashings become too loose, the item will lose contact with the deck and slide. Even minor longitudinal or transverse acceleration forces carry the risk of cargo shifting. But in extreme conditions, when rolling angles can sometimes reach 30 degrees, the risk is very much greater. When an item moves, it slides and then stops. In rough seas, this movement becomes repetitive and increases as the lashings become looser. The item then moves faster and travels further until it could break free altogether. Acceleration forces apply throughout the ship, but they increase further from the center and are greatest at the extremes. The IMO has provided information on acceleration at sea by a simple and comprehensive table showing basic acceleration data in all stowage places on a vessel. The data presents the maximum values to be expected in the longitudinal, transverse, and the vertical direction of the ship. To apply to ships of any size, speed, and stability characteristics, there are simple correctional factors available.